recurrence relations with regular payments. So far we've looked at situations where someone might come into a bank with some money and then invest that money as a one-off payment. But in reality, many financial problems require more than one payment. In fact, they'll have a regular payment over a period of time, and that's what we'll look at in this video. A $300,000 home loan at 8% per annum is paid in $27,000 annual payments. So the interest increases the amount owed, but the payments decrease the amount owed. To do this problem, we need to do a bit of background work. To increase by 8%, that's the same as 100% plus 8% is equal to 108%, which is the same as 1.08. So to increase by 8% each time, we multiply by 1.08, which is our R value. After multiplying by R, we need to minus the payment. To work out example 1 as a recurrence relation, our V0 is equal to 300,000, which is our principal, the amount borrowed. To get the next number in the sequence is equal to 1.08, which is our R value, multiplied by Vn, take away 27,000. So to work out V1 is 1.08 times 300,000 minus 27,000 to give us 297,000. To get V2, this time the 1.08 is going to multiply by 297,000, and then we keep taking away the 27,000. And we keep following that through. There is a way to do this on the calculator. Put 300,000 into the calculator and then type this in, 1.08 times the previous answer minus 27,000. Most calculators should be able to do this. And then once you've got that set up, you can literally keep hitting enter and it'll keep giving you the answer for each time period. To do example 1 as a formula, you would need to use this monstrosity here. Now you can substitute in and get the correct answer, and you can pause the video and give it a go, but there are far better methods like using recurrence relations. How much is owed on a home loan is a curve bending down. However, after a short period of time, it looks like a straight line. If we look at it over a longer period of time, we can see that it's a curve bending down. Example 2. A $300,000 investment at 8% per annum pays $27,000 annual payments. You might think that this is the same question as example 1. And mathematically you are right. Conceptually it is different, but the mathematics are exactly the same as what we did in the previous example. So let's recap home loans. Interest increases the amount owed, payments decrease the amount owed. The more money you pay off the loan, the faster the loan decreases. Recurrence relations are the best way to think about home loan problems. The mathematics is the same if you have an investment and receive a regular payment from it. $25,000 is invested at 7% per annum with payments of $10,000 each year. Both interest and payments increase the amount saved. To increase by 7%, 100% plus 7% is 107%, which is the same as 1.07. To increase by 7% each time, we multiply by 1.07, which again is our capital R. After multiplying by R, we need to add the payment. So to do example 3 as a recurrence relation, V0, our principal, is 25,000. To get the next number in the sequence is 1.07 times the previous number plus 10,000. We add 10,000 because we're adding to our investment. V1 is equal to 1.07 times 25,000 plus 10,000 gives us 36,750. To get V2 is 1.07 times the previous number, which was 36,750, plus 10,000, which gives us 49,323, and we keep working through like so. Example 3 can be done on our calculator. We start with 25,000, and then we put in 1.07 times the previous answer plus 10,000, and then from there it is a matter of keep hitting enter and you'll get all your numbers. You can use a formula for example 3, not that I'd recommend it. It's the same formula as the home loans, except that we've got a positive rather than a negative here highlighted in red. You can substitute in and get the right answer, but I highly recommend using recurrence relations. When we graph this, it looks like a straight line, but it's because we're doing it over a short period of time. There's actually an upward curve here. This upward curve looks more pronounced over time and looks just like the compound interest formula. Here is a compound interest graph using the same information as our previous example, however there are no payments, and it looks like a similar curve, but this is a bit deceptive. The reason why the two graphs looked the same was because they had different scaling on the y-axis. But when they're on the same axis, you can see that the compound interest with payments has a much steeper curve. Let's recap. Interest and payments increase the amount of investment. The more you invest, the faster the investment grows. The shape of the graph is similar to compound interest, but payments make the upward curve more pronounced. Let's review. When we combine addition or subtraction with multiplication, we can model investments or loans with payments. Conceptually, recurrence relations are the best way to think about these types of problems. Thanks for watching. Please subscribe and hit the like button. Please leave a review and a comment. I'm not a financial advisor. I'm an experienced mathematics teacher with a passion for teaching financial literacy. Please read the disclaimer.